Hello class, today's lecture is aquatic therapy. I don't know why chapter 13 is there, but we'll go with it. Chapter 13, aquatic therapy. Here we go. Objectives. Identify the physical properties of water that affect the ability to exercise in water. Explain the difference between assistive and resistive aquatic activities and equipment. List precautions and contraindications for aquatic exercise. Identify advantages and disadvantages of aquatic therapeutic exercise. So let's look at the physical properties of water. So first, specific gravity or relative density. The density of object is relative to that of water. So the specific gravity of water is 1.0. So we all know from science that if the object is greater than 1.0, it'll sink, and if it's less than 1.0, it's going to float. So specific gravity of humans is variable depending on the composition, and it is also variable with different body parts. So fat is going to float, it's 0.8. Bone's going to sink, it's 1.5 to 2.0, so it's pretty dense. And then lean muscle we know is primarily made up of water, so it's going to be about the same as water. So it's about 1.0. So the average specific gravity of humans is just a little less than that of water, so we tend to float just a bit, but not much. We're not that much lighter than water at 0.95 to 0.97. For some people that are lean, it may be as high as 1.1, or for somebody that is obese, it may be 0.93. So buoyancy. That we base buoyancy on Archimedes' principle. It's an immersed object will experience upward thrust equal to the weight of the fluid the object displaces, and this is closely related to specific gravity. So you can do this in a pool. So if you have a beach ball, a small beach ball, you can stick it underneath the surface of the water pretty simply, and wherever you let go of it, it's going to fly up out of the water. If you have a small ball, it won't come out of the water very high. But if you were able to push down a big ball, like an exercise ball or physio ball, one, you're going to have trouble pushing it all the way underneath the surface of the water because of the upward thrust, because of the amount of fluid that is being displaced by this big ball. And then once you get the ball underneath, then you let it go. This upward thrust is going to make the ball go flying up in the air over your head. Whereas if you just took a Coke bottle that's halfway full of water, it's still going to float, but whenever you pull it underneath the surface of the water, one, it'll go underneath pretty easy, but then two, whenever you let go of it, it'll just resurface. It won't actually fly up out of the water. So there's a fun little YouTube video there that you can, maybe you can cut and paste it and see a little David Letterman for you there. So our center of buoyancy is, center of gravity is the displaced fluid and the point at which the buoyant forces act on the body. So these are two opposing forces. So the buoyancy is an upward force, whereas gravity is a downward force, and each has its center point of balance. So you get equilibrium when they're in vertical alignment. So whenever you're upright, you have equilibrium point because the center of gravity and buoyancy are vertical, but as you start leaning forward or backward, you start losing that. So hydrodynamics, so a couple of terms here. We'll talk about some different forms of drag, and we'll talk about viscosity. So viscosity occurs due to the friction between water molecules and the object moving through water. So we commonly hear the term viscosity used whenever you think of motor oil. You always see these commercials that talk about having low viscosity because the purpose of the oil is to reduce friction. So that's the friction between the water molecules and the object moving through the water. So if you've watched the Olympics in recent years and compare to the Olympics, maybe whenever you were a little kid, you see that their suits are much different now because they're trying to reduce the amount of friction in the suit that they've designed. You also see swimmers that will shave their hair on their body because that adds a little extra friction. So they'll do those two things. Now they tend to instead just wear the full body suits so that they get the least amount of friction to occur between them and the water as they move through. So drag is the water's resistance to a body moving through it. So we see down in the pictures below, you see something that's streamlined. So if you have a paddle board and you turn it sideways and walk forward, then that paddleboard is not going to create any drag. Whereas if you take that paddleboard and you turn it sideways, and now the front of it's facing into the water, you're going to get a lot more drag, and it's going to be a lot harder for you to walk through the water. So that's determined by the object's size and shape, is the form drag. And then you get wave drag, which is the water's resistance due to turbulence. So you don't have as much wave drag whenever you're underneath the surface. And if you're on the surface, like if you're riding in a boat, it creates a wake. The bigger the boat, the bigger the wake. The bigger the boat, the bit faster it goes, the bigger the wake it has compared to going slower. So we have wave drag whenever we're walking through the water. So if we're walking at a slow speed, we may only have 5 to 6 times that of the resistance of air. So we have a lot more friction between us and water. But whenever we run in water, now all of a sudden it has a greater resistance, up to 40 times that of air. And then lastly, we have frictional drag, which is a result of water surface tension. So we know from science that we have this surface tension that has to be broken. So that's the reason that you'll see, like in diving competitions, they'll have that little stream of water that's flowing out there to help break that surface tension for whenever they enter the water from a dive. Now let's talk about hydrostatic pressure. So Pascal's law states that pressure from a fluid is exerted equally on all surfaces of an immersed object of any given depth. So if you're sitting in 1 foot of water, laying in the pool, in a little kiddie pool at 1 foot of water, you got the same amount of pressure that is exerted on you. If you dive down to the bottom of a 10-foot pool and now you're laying on the bottom of that, you're going to feel a lot more pressure. So if anybody has scuba dived before, you understand this. You know how the deeper you go, you feel pretty well, you feel greater pressure the deeper that you go. So you see here from the diagram that the atmospheric pressure is 14.7 pounds per square inch. At 1 foot, you add 0.43. At 2 feet, you add another 0.43, and so forth and so forth. So the deeper you go, the greater pressure you have. So if you are a 7-foot person standing up to your neck in water, your feet are going to feel more pressure than if you're a 4-foot person standing in 4 feet of water up to your neck. You'll also, if you've ever worn waders and walked in water, you definitely feel this pressure. So as you first step into the water, you feel the water form the waders around your ankle and your lower leg, and as you get deeper and deeper into it, you feel more and more pressure at your feet. So let's talk about weight bearing in the water. So you get less weight bearing as the depth increases. So if you're standing about in your waist, you see at the diagram there, you're getting about 50% of your body weight through your lower extremities, so into your feet. The higher the water gets on you, so now if you're up to your chest, now you're about 25 to 30% of your body weight. And then if you get all the way up into your neck, then now you're only at about 10% of your body weight. So what you'll find is it's fairly easy to walk, and to walk heel to toe, and to keep equal pressure on your feet whenever you're in waist deep water. But if you're trying to walk in water that's up to your neck, or if you try to walk submerged, you really can't keep your feet in contact with the bottom of the pool very well at that point. So if we're walking at a slow speed in water, then we can maintain that 50% weight bearing, but it's going to increase the faster we walk. So if we're walking in waist deep water, the faster we go, now the impact, we get greater load, so now we're going to get more weight bearing. Body type also plays a part in this. So a male and female are going to weight bear differently. Somebody that's very thin and skinny is going to weight bear differently than somebody that maybe is obese. So at your xiphoid process, a female is going to weight bear 28%, whereas males are going to weight bear about 35%. So let's talk about some indications and some advantages. So indications for using aquatic therapy. So any signs or symptoms associated with musculoskeletal injury, pain, edema, range of motion loss, weakness, restricted weight bearing. You can also use aquatic therapy for cross training. I know our track and cross country team uses the pool quite a bit to cross train because in the pool they're able to get some work in, but they're not getting the weight bearing and the impact, and they're not getting the load on their joints as if they're running outside. Some advantages to aquatic therapy is we're able to increase the exercise intensity, especially with a non-weight bearing or a partial weight bearing individual, or with somebody that maybe their weight bearing status is full weight bearing but they're load sensitive, so they're unable to put full weight on their leg. So getting them into the pool allows them to walk more comfortably and to weight bear through that joint without causing pain. So the buoyancy reduces the compressive forces of our body. So if you have somebody that has a low back issue, we can get them in and do some deep water running, and they're not getting the compression that they get with running on a treadmill or running on the ground. We also have greater freedom of movement, so we can, especially in lower extremities, we can stride out a lot farther than we can. We can get increase our base of support. We can get outside of our base of support more, and we don't have to worry about falling or damaging a joint, because the worst thing that happens to you in the water is you get your hair wet, whereas on land, the worst thing that happens is you fall down and break something. Warm water can also reduce pain and promote muscle relaxation. So especially with an elderly individual, maybe just getting in, maybe they have arthritis, just getting in the pool, the warmth of the water helps to promote reduction of pain and helps them to relax. An early initiation of aquatic therapy can foster the development of a healthy attitude, promote body awareness and balance, and decrease stress on healing tissue. Some precautions of aquatic therapy. Some people are afraid of the water. They don't like getting in the water. Maybe they can't swim. So that's something that we need to take into consideration if we're going to put somebody in the pool. Well, if they can't swim, make sure that they're aware that we're not going to get in the deep end. We're going to stay in waist deep water. If they fall down, all they have to do is stand back up. Somebody that takes medications that affect their heart rate, their blood pressure, or their respiratory rate, somebody that has chronic ear infections, somebody with seizure disorder, maybe they have a chemical sensitivity or allergy to the pool chemicals or to the chlorine that's in the pool. And then some strict contraindications. So we don't want to put anybody in the pool that has a contagious infection. If somebody has surgery, we want to wait at least 7 days. We want those incisions to heal up. If the incision's not fully healed or if it's still oozing, we're not going to put them in there. Medical conditions, we don't want to put somebody in with a trach or a DVT. We don't want an incontinent individual getting in the pool. We don't want to find a baby Ruth in the pool. Somebody that has uncontrolled seizures. You definitely don't want somebody having a seizure in the water. That would be a very dangerous situation for the individual as well as somebody trying to save them. Some disadvantages of aquatic therapy. Number one is the cost. So building a pool is not cheap. Maintaining a pool is not cheap. Convenience or availability. We're in the same building as a pool. Sometimes it's just not easy to get down to the pool. There's also availability. We share that pool with the university. We share it with outside groups from the community. So sometimes we cannot get to the pool here. And then an indoor pool versus an outdoor pool. Of course, an indoor pool is going to cost a lot more to heat it, to maintain it. An outdoor pool, you can only use it for a certain number of days or months out of the year. So once the weather starts turning cool, now you can't really use that pool anymore. You can't really work both concentric and eccentric phases in a single exercise. On land, if you're doing a biceps curl, you lower it down for the eccentric phase, you pull it up for the concentric phase. If you're in the pool, if you're doing a biceps curl, and you're using a floating weight, that floating weight is pulling you up. So you're basically using your triceps rather than your biceps, doing the same exact motion, because now you're pushing down that weight, that floating weight that's trying to rise to the surface, and then as it's rising back to the surface, you're getting more of an eccentric phase out of that. But really it's just controlling it, so you don't get as much eccentric as you do on land. It's difficult to gauge the intensity of exercise activities. So you may have somebody that feels great in the water, but as soon as they get out, they are worn out. So it's real easy to exceed an individual's capacity. I remember the sorest I have ever been was after a pool workout. My calves were so sore, I don't know that I could walk normal for about 3 days. And so then we have to remember that our hydrostatic pressure is not consistent throughout our movement. So we may have the deeper we are, the more pressure that we have, the more close to the surface we are, the less pressure that we have. So that is the lecture for today. We are going to use our lab time or our class time strictly in the pool. Whenever you arrive, we'll go to the pool, or we'll actually meet at the pool. So wear your suits and something decent and harding appropriate. I'll see you at the pool.